This is problem 46 from chapter 17. A 7.7 microfarad capacitor is charged by a 165 volt battery and then is disconnected from the battery. When the capacitor C1 is then connected to a second uncharged capacitor C2. The final voltage on each is 15 volts, and the problem is to find the value of C2. Given is C1 equals 7.7 microfarads. This is the original set drawing, and then once disconnected from the battery, C2 takes the place of the battery. So we're going to start by converting 7.71 microfarads to farads. So what we will do is 7.7 microfarads times 10 to the negative 6, which is the conversion rate for farads, over 1 microfarad, which is then going to equal 7.7 times 10 to the negative 6 farads. So now plugging into the equation, Q equals CV. Q is our unknown. C is going to be 7.7 times 10 to the negative 6 farads, multiplied by our voltage on the battery, which is 165 volts. This can then be calculated out to be 1.27 times 10 to the negative third for our Q value. Then the battery is disconnected and the charge remains constant. And the capacitors, since they are in parallel, the voltage across the two is going to be equal to 15 volts. So we are then going to use this Q value and plug it in to that same formula. So Q equals CV. Q equals, this is for Q1. Q1 equals 7.7 times 10 to the negative 6 farads multiplied by the 15 volts, which is our final voltage across the two capacitors. This comes out to be equal to 1.15 times 10 to the negative 4. The total charge is then conserved. So we can use the equation Q equals Q1 plus Q2 to find out what our Q2 value is. Rearranging this formula, we find that Q2 equals Q subtracted by Q1. So plugging into the formula, we find that Q2 equals 1.27 times 10 to the negative third subtracted by 1.15 times 10 to the negative fourth coulombs. So Q2, after some math, is equal to 1.15 times 10 to the negative third coulombs. So to solve for C2, we can then use our value for voltage, that is the final voltage, 15 volts, and we can use this Q2 value to solve for C, or the capacitor 2. So what we are going to do is rearrange the formula. So we have Q equal to CV. Rearrange it to make C2 equal to Q2 divided by V, which is our voltage. We then plug in, so C2 equals 1.15 times 10 to the negative third coulombs divided by 15 volts. Then after some math, C2 is found to be 77 times 10 to the negative 6 farads. And this is our final answer on how you find C2 in problem 46 of chapter 17.